Antenna Technology's Simulsat multi-beam antenna is the most versatile satellite antenna available. It allows a full 70 degrees of simultaneous satellite reception with uniform performance on each satellite. Antenna Technology's field services for Simulsat antennas include new installations, feedbox retrofitting, which expands older Simulsat antennas' receive capabilities to the full 70-degree domestic arc, and service of existing sites, all of which include feed peaking. Movement of satellites and programming makes it necessary for all Simulsat users to be able to peak their satellite feeds. This video is an instruction of satellite feed peaking on a Simulsat multi-beam antenna. Feed peaking is the process of locating a satellite feed in the phase center or focal point of a satellite antenna. On a parabolic satellite antenna, this involves aiming the dish in azimuth and elevation and polarizing the feed until it is peaked. On a Simulsat antenna, the process includes correct aiming of the antenna in azimuth and elevation, and additionally includes setting the correct roll angle of the Simulsat. But the actual peaking of the feeds is done individually in the feed box. The tools required for peaking Simulsat feed assemblies are a 5/32 hex key, a 3/16 hex key. We recommend ball-end hex drivers because of their ability to access socket head hex screws at odd angles, a 5/16 wrench, a felt tip marker, a pair of feed box spacer bars. Spacer bars are available from Antenna Technology, and a ladder or a bucket truck. In most locations, a 28-foot extension ladder will suffice. The electrical equipment recommended for the job includes a satellite receiver, a video monitor, a low-noise amplifier or low-noise block-down converter, and a spectrum analyzer. At Antenna Technology, we have found that the Vanguard Instruments VI 2.0 spectrum analyzer has the features and performance that make it the ideal spectrum analyzer for satellite feed peaking. The VI 2.0 is a compact spectrum analyzer, satellite receiver, and monitor in one. The VI 2.0 provides power to the LNB, has an internal battery, and has an acoustic level indication to facilitate feed peaking. The VI 2.0's combination of features in a compact, easy-to-handle package make it the right tool for satellite feed peaking and an economical choice in satellite equipment. For more information on the VI 2.0 spectrum analyzer, contact Antenna Technology. Additionally, you will likely need an extension cord, various RF connectors and adapters, and some jumper cables to make the necessary connections. For feed peaking, the Simulsat antenna must be properly aligned. A properly aligned antenna will allow feeds for satellites in the entire U.S. domestic view arc to peak within the confines of the feed box. The U.S. domestic arc extends from SpaceNet 2 at 69 degrees west longitude to C1 Aurora 2 at 139 degrees west longitude. If, while peaking, you run the feed assembly into the side or end of the box before seeing the power level of the signals drop off, your antenna needs realignment. If you need assistance with the alignment of your Simulsat, call the Antenna Technology offices. An important part of peaking Simulsat feeds is to set up the equipment used for peaking in or on top of the feed box. This way you get immediate feedback and can zero in on the peak more quickly and accurately. If possible, peak feeds in the early morning or early evening. Sunlight can make it difficult to see the analyzer display and the video monitor. Simulsat feed assemblies allow adjustment in azimuth, elevation, focal length, and polarity. Frequently, the first thing to be done after setting up is to locate the desired satellite in the feed box. Your view of the satellites looking into the feed box is the same as your view of the satellites in the sky looking south. That is, SpaceNet 2 and Satcom F4 are to your left, and Satcom F1 and Galaxy 1 are to your right. Feeds can be located generally by connecting a bare LNB to a spectrum analyzer and scanning in the feed box. When looking for feeds this way, be careful to keep the LNB polarized correctly. Certain satellites have distinct signatures and can be easily located. For example, F4, G3, F1, and G1 have many video carriers and can be easily recognized by the large number of carriers displayed on the spectrum analyzer. Scanning from the west end of the feed box, the first satellite you find that displays peaks on all 12 transponders is F4. Once F4 is located, you can gauge where satellites are in the vicinity of F4. On average, for a Simulsat 5 antenna, 1 degree of satellite longitude is equal to 2 inches of azimuth travel in the feed box. SpaceNet 3 is 5 degrees west of F4, so approximately 10 inches to the west of F4, you will find S3. The same goes for the other side of the feed box. G1 and F1 can be found by scanning in from the east end of the feed box. Once they're located, other satellites can be found in relation to them. After finding the desired satellite, make a mark in the feed box window to facilitate relocating the spot. You can now do a quick check of this location to make sure you are on the right satellite. Set the elevation adjustment of the feed assembly to approximately where you expect to get a peak. Secure the focal length adjustment of the feed assembly. The polarity will usually be just about at right angles to the feed box. Loosen the track bar fastening screws. Connect the analyzer to the feed and briefly peak the feed. The carrier levels in the analyzer display and the acoustic level indication will rise as the feed approaches the best location and fall as the feed is moved away from the best location. Locate the feed where the carrier levels are at their highest. Secure the feed to the track. Switch to the receiver mode, or if you're not using a VI 2.0, connect the feed to a receiver and monitor, and verify the satellite by checking the programming being received against the program listings of a satellite TV magazine. Once satisfied that you're on the right satellite, you can begin peaking. Begin with the feed assembly setup the same as in verifying the location of the feed. That is, set the approximate elevation, secure the focal length and polarity, and loosen the screws that secure the azimuth of the feed assembly. If necessary, adjust the distance between the feed box tracks using the spacer bars. The feed assembly should move easily on the feed box track. Connect the feed to the spectrum analyzer. Hold the feed assembly slightly above the feed box track and move it side to side. The carrier levels in the analyzer display and the acoustic level indication will rise as the feed approaches the best location and fall as the feed is moved away from the best location. Locate the feed where the carrier levels are at their highest. Seat the feed into the track at the best spot. Mark the track. Repeat the process using the track marks as a reference. When you are satisfied that the feed is at its best location, secure the feed onto the tracks. Peak the elevation by zeroing in on the best spot. make a reference mark on the feed assembly. Repeat the process using the mark as a reference. When you're satisfied that the feed is at its best location, secure the elevation. After the azimuth and elevation are set, adjust the focal length of the feed. Adjust the polarity by rotating the waveguide portion of the feed assembly. Set the polarity so that adjacent polarities are nulled. The feed is now peaked. There are many things that can make feed peaking difficult: terrestrial interference, sun outage, LNB failure, bad connectors, inclement weather, satellite center of box status. This is only a partial list. If you've gone through the basic steps of feed peaking and are still having trouble, call the Antenna Technology offices, area code 602-264-7275. Antenna Technology carries LNAs, LNBs, filters, adjustable bandwidth receivers, and terrestrial interference edge absorbers, which can help to improve signal levels. If necessary, Antenna Technology can provide field service to address signal level problems or perform periodic maintenance. The Simulsat multi-beam antenna can provide a remarkable amount of satellite service from a single platform. Once installed, the only requirement for easy expansion or change of service is a feed assembly and the ability to peak it. Where adding an additional parabolic antenna can be an arduous, time-consuming, and expensive task, expanding service on a Simulsat can take as little as 1 hour.